Welcome, everybody, to another edition of the Southwest Climate Podcast. Michael.
Hi, Zachary. How you doing?
Zachary, huh?
Yeah. Yeah, it's actually my son's name when he's in trouble. Right. So, happy end of monsoon. Happy beginning of the new water year. Happy Halloween.
I guess just a couple days ago, the official end of the monsoon happened.
Good riddance.
Boy.
It was a weird one.
How so?
Don't you feel like it was a weird one? What's your take on it? What's the emoji you would post for this monsoon season?
I kind of give it a shrug.
Would you? That's good.
Yeah.
I like that.
It'd be a shrug. What about yours?
I'd like that kind of fake smiling grin like, yeah, that was okay.
Like you want to say something else.
Yeah,
but
exactly. Right.
You're kind of like holding it in because you don't know if people are going to be judging you.
Exactly.
I see how you go. Yeah. So let's spend this episode putting a bow on the monsoon 2019.
Or cleaning it up and putting it in a bag. You could put a bow on it if you want, I suppose.
We'll do both.
Okay.
You know, we actually have quite a bit to talk about in terms of September. September was an interesting month.
It was an interesting month, yeah.
It was not, or it was?
It was an interesting month. I'm not sure it was a monsoon month.
I think that's the topic. Did September's rain event, if you will, change the story at all? We'll have to break that down. Let me just do the roundup of the June through September monsoon in its entirety and try to put this in a climatological context.
That's what we do.
And I'm just going to name off some of the major cities / areas where I found station data that will help us get the sort of spatial picture here. So we'll start with Tucson. Tucson was the 24th driest on record, and there's 72 years in that record.
Do the math.
All of these stations have a slightly different period of record.
Right.
So the 24th driest out of 72 years. Obviously, that would be below median.
It's good.
Okay, so Phoenix, moving west now, third driest out of 73 years.
Right.
Prescott, ninth driest. Flagstaff, driest.
Yeah.
And Flagstaff has a record of 70 years. Okay, so now we'll move over to the White Mountains. Show Low only has 18 years in this record, but it was the driest.
Really?
Yep.
Oh, boy.
And then let's go over to Albuquerque, all the way up north. So the real fringes of the monsoon. 12th driest out of 74. El Paso, all the way down, border between New Mexico and Texas, more or less. 7th driest. They're all dry here.
They're all dry. Yeah, there's no winners here.
I think people get the picture.
I think, yeah.
Yeah, so this will come in. I don't have the full Arizona as a whole record or rank yet. That data from the NOAA NCDC is not quite in. I don't think it's going to be a record, but it's going to be in the top 10.
So if we look at some of the preliminary data, say from the Westwide Drought Tracker, so we use some of the PRISM data, July, August, September, for Arizona, we can look at the pattern, and it follows exactly what you said. So this is a record, a gridded precipitation record that goes back to 1895, and most of northern Arizona is in the record driest. So that Flagstaff observation locally extends all the way up through much of Coconino, into Mojave County, and up through the Four Corners with Hopi and Navajo. And it extends actually into Utah and southwestern Colorado, and then the northwestern part of New Mexico too. So there's sort of a bullseye around the Four Corners and into northern Arizona, that July, August, September monsoon season, driest on record. Yeah,
interestingly, the far southern tier of it it's just below normal, and it's not like slightly below normal. So we're not talking extreme bottom 10 percentile or drier, and that's probably going to lift the Arizona aggregate value slightly.
Yeah, it won't come in as the driest on record for the whole state for JAS, July, August, September, but it's a pretty dubious distinction for a lot of the locations in northern Arizona.
Yeah, absolutely. I will say this, though. The June, July, and August rank for Arizona in aggregate was the driest on record.
It was the driest on record, right.
And what might have changed the game slightly is that in September we had an incursion of remnant tropical storm that really doused quite a bit of central to southern Arizona.
Very weird maps now when we look at the monsoon totals. I think if we look at this monsoon season in aggregate, if you look at a line that kind of carves out, so if we think about the monsoon season activity, if you go from southern Arizona, sort of Pima County, up through Graham-Greenlee County, and then you go straight to the northeast up through New Mexico, anything south of that line, it was a monsoon, not a great monsoon, but something a little bit more, what we would expect. And everything north of that was just a mess. It was much quieter, unusually dry, the humidity was even quite low for parts of the northern part of the state, given we'll talk a little bit about some of the dynamics behind that, than you'd expect for a monsoon season.
I mean, Flagstaff really had one day where there was a decent greater than a quarter of an inch of rain. Just one day.
One day.
It's total. And Mike, you and I we're sort of drawing from different data sets, so maybe we ought to just talk about that a little bit. Mike was referring to when he was using the West-wide drought tracker, the PRISM data. That's a gridded data set.
Yep.
That goes all the way back to 1895.
Yeah, so it's an interpolated data set. It's mostly based off of stations. So that Flagstaff station would be in there. So its rankings they're not quite as sort of empirically obvious as the station data that you're pulling.
And I'm drawing off of the station data.
Yeah, so it's the station data is the actual rain gauge observation in mind. But still, I think it's still reasonable to look at that longer term record, and it's consistent, right? It's consistent between that station record being shorter and this longer interpolated record.
Yeah, and the gridded data sets are important because they help us understand there's not a lot of stations out there.
That's right.
There's not as many as we would like.
Right. Yeah.
The station record here at the Flagstaff Airport, again, goes back 70 years. So 1950, 2 inches, a little over 2 inches. And normally the average is close to 8. So, I mean, that is substantially, we're talking at 25% of average.
Yeah. Yeah.
Driest on record.
For the summer. Just hard to do to get that low in the summer. Quite honestly, with respect to the historical records, that getting 25% of average in the wintertime, we do that all the time across Arizona.
So we talked about in the last podcast more or less what happened in June with the late and July with the late onset, and we sort of broke down a little bit August. I think now we should focus our time on September and September more or less, Mike. September for again looking at Tucson. Prior to the incursion of that tropical moisture, which we should spend a little bit more time talking about, there were a couple days where we did have widespread activity, seemed to pick up a little bit, at least in my recollection in September. But really the event of note is what happened at the end of September with this recurving tropical storm Lorena in the East Pacific that really brought 4 days more or less of rainfall up to Phoenix and for the most part in southeast Arizona. What happened with that event?
We can do this by thinking about that event and then kind of working backwards, because what happened with this event. So first off, what happened with this event was we've had an active jet stream pattern going back all the way to last fall, back to last Christmas even, right? And so we had this sort of wet storm track across the southwest. We've seen a lot of sort of troughing across the west. Active weather pattern, bringing the storm track down south here. And then when we got into May, we ended up having a very cool, pleasant May, quite a bit of snow up in the Southern Rockies. And I'm sort of building this all the way forward because that pattern really hasn't gone away largely.
The active jet pattern.
The active jet pattern. And when we got into June, I just said, forget it. It's going to go away. We're going to go back to climatology. We're going to have the ridge come in. And I was totally playing the climatology. Well, by the end of June, we had forecasts that were suggesting that July was going to be drier than average, later onset. Absolutely, that's what happened. And then we even saw in the seasonal forecast from the Climate Prediction Center, this expectation of an active East Pacific tropical storm season would kick in at any moment and would enhance the precipitation. Once we got online in July, we'd start to see that pick up in August, and we'd have it carry through in September. Right. So that was that's the setup, right?
A fairly good forecast.
Yeah, it's a good narrative, right?
Yeah.
It sounds like a good narrative. And, we look back, I look back at the forecast, and Climate Prediction Center had a couple of shrugs with equal chances we went through there in the 30-day forecast or the 3-month forecast. As they were updating in July, August, and September, we still kept there's still this hope was alive that we would get wet, like the pattern would turn wet. And I do think it was because of the expectation of having access to that moisture. But what ended up happening was July was late and ended up being drier than average. August ended up being just not good. August was, the entire state was below average as far as precipitation. A couple of spots got lucky and had some locally heavy downpours that put them above average. But by and large, almost all of Arizona was in its bottom 10% of total precipitation for August. And I'm using the PRISM data. And New Mexico didn't do much better either. They were below average for the whole state. So the trouble kept going. And then September, we're now kind of in that transition. We're expecting transition season, expecting those tropical storms to come online. Man, the monsoon pattern literally just packed up and left the first week or two. And we were into a full-on transition, kind of like a late fall, early winter pattern. And that's what set us up for the end of September event.
So you said a lot of interesting things there. I want to go back to this.
Which ones?
No, but it was this idea of this active jet. That didn't go away. And so by active jet, you mean that the jet stream itself was loopier. It was more circuitous.
I can't put a wave number on it. I don't know that for a fact, but what I do know, and you see this in some of the National Climatic Data Center puts out a really nice discussion every month. It's lagged by a month, and I was telling you guys, I was reading it before. Well, they actually pointed in August that the Arctic oscillation was negative, right? And so we typically don't talk about that in the summertime. We talk about it in the wintertime, right? A negative Arctic oscillation means that the jet is displaced south. And when it's displaced south, it tends to have a little bit higher wave number, a little more wavy action with it. Well, that discussion was sort of suggesting that some of the patterns across the continental U.S. were related to that.
But I guess that's pattern. What I'm trying to understand this. So can we think of this like it was a collision between this active jet that was pushing down, airflow pushing down south, versus what typically happens is you get this high pressure ridge that builds in and sort of progresses north as you go into the summer, and it moves slightly to north of southern Arizona. It's when we're in more favorable conditions for moisture from the south to waft in there. And so can we think of this as a battle between the two?
Yeah, I think so. And in under best case scenario, the polar jet has retreated to the far north, up around the poles. And that would even, in an extreme example, would be a positive Arctic oscillation where it's kind of really
bottled up.
Yeah, there. It's tight up around the poles. In that situation, you'd end up having a large sprawling upper level ridge develop across the western U.S., even the continental U.S., and we'd be under stagnant conditions underneath that ridge. And as you're suggesting too, is that if then that puts that ridge axis further north, we're into a better easterly fetch with having that ridge position and that high north of us. So it's not an active mid-latitude weather pattern. We're in that sort of stagnant subtropical air mass on the south side of the high. And we also then have better chance of getting any of those sort of easterly waves that will work their way in the easterlies on the south side of that upper level ridge. And we just didn't have that this year.
What about more favorable conditions to receive moisture from Gulf surges as well?
Yeah, absolutely. I mean, it all kind of fits together too. And having that ridge axis north of us and being on the slightly cooler side as you get away from the center of the ridge makes it a little more favorable thermodynamic environment. I think it also would help the progression of easterly waves across Mexico to trigger the pressure differences up the Gulf of California that would cause the Gulf surges. We had this real tension here, and it was, I think the tension, if you look at some of the maps throughout the summertime, you look at the upper level wind flow pattern, was that active weather pattern was just to the north of us, right? And I think it really was a battle of sort of a transition pattern the whole summertime. And if you look at some of the metrics like the humidity and dew point, some of the thermodynamic parameters from the radiosondes, they weren't great, but they weren't terrible. Like it wasn't just bone dry. It wasn't like May, or it wasn't like June here all summer. It was uncomfortably humid. We had plenty to work with, but just given, I think, with the high overhead, we had miserable inversions in the thermodynamic profile. So we ended up having warm air at the wrong spot in the atmosphere. So the storms would run into them and then just die.
I kind of think that's the story. It's that for the most part, there were the classic ingredients needed for a relatively decent, a monsoon that was better than we ultimately experienced.
Yeah,
right?
yeah.
It was that there was moisture around.
Yeah.
It wasn't like we were lacking for moisture.
Right.
Yeah, the position of the ridge seems like it was a little bit further south, or maybe it spent more time than otherwise in a less favorable position. But there were still moments within our monsoon where we had enough moisture around and the position was in a favorable location, and the dew points were, this relates to precipitable water around, the dew points were in above average levels. And the sort of thermodynamics weren't, you mentioned inversions, maybe these metrics that we think less about, but that kind of play a pretty critical role.
Yeah.
And those weren't, I mean, I don't know how to say this. We've said this before. It's like, it is kind of magic that we get rain at all.
Right. Right.
Because all of these things have to come together. But it does seem like that this year, that maybe that atmospheric profile was a little less normal.
Yeah, I think so. And I'm thinking sort of synoptically, and I know this isn't the primary determinant. We can't just hinge it all on this ridge position. I think there's other sort of moving parts. But I think it does help if you look at that upper level weather map through the summer. It wasn't that great ever. We had a couple of days, if you look at the weather map, where it was in the right position, and those tended to deliver.
So in other words, that high was just, it was in a favorable position very
infrequently for this. And so, and the other interesting thing that I think that Southeast Arizona was able to capitalize on more of those days than the northern part of Arizona. And New Mexico largely had a kind of a different monsoon about when the events occurred and, you know, how they accumulated precipitation throughout the season. So you can kind of carve it up in these parts. Being here in Tucson, it really wasn't a bust. And if you look at the airport, had a rally, came in, you know, it's below median. It's not the driest on record. It would have been a lot worse shape if it didn't get a bunch of that rain in September. But there are parts of Tucson, when we look at RainLog and we look at some like Kokoraz and the other volunteer networks, flood control gauges, there were places that did above average. So, and they're like, if you look at Tohono, the Tohono Nation off to the west of us, they got clobbered multiple days. And then one of the strangest stations that stands out this summer is Ajo. Ajo came in above average. So it was like a low desert station. So it doesn't fit. It doesn't even make sense with the context of how the monsoon storms evolved this year, that a lower elevation station far out west would have done it. But it was like it got lucky being in that spot. But
going back to that, it wasn't a bust for Southern Arizona, which I agree with when you step back.
It wasn't great. I mean, I'm not trying to shine a, you know.
Well, people have thrown around monsoon. I mean, I heard more monsoon.
It's sketchy. I think we probably said it. The last podcast title was Monsoon. We're owning it.
Right.
We've even been given credit for it, even though it's not ours.
Here. You know,
we're
just parroting what other people are saying.
Oh, that's all we do. Yes, that's true. Yes.
People have been calling this monsoon more or less a bust. You just did. We put it in our title last time. And your comment a minute ago was, when you look at Southern Arizona and Tucson in particular, we're close to 85% of average, which is not that bad, but
it's a B.
Yeah, it is. It is a B. Would you take a B
plus?
When you're in school? Would you take a B, or were you upset at a B?
It depended. It's
what kind of student were you?
Different phases of my life. I was a pretty good student. Yeah, it was. But I had moments where
I was angry with the B.
Were you really?
Yeah.
Oh man.
Okay, I digress. No, but what I was going to say is that if you take away the 2 inches or so, no, it was actually 1.25 inches in Tucson that came from Lorena at the end of September, I think it's a very different picture.
This is the thing that is, I think, maddening about the monsoon that I'm not sure we're ever going to solve, was even without that 2 inches at the end of the monsoon, there were parts of Tucson that had gotten plenty of rain. Even without that event, there were places that were on track to be average.
Less places we're on track to be average.
That's totally right. But
average.
that's the nature of the monsoon. Right. So the bust, you can think
but
about this.
But I think you have to look at that. Sorry to
yeah,
interrupt.
Sure. No, I see where you're going with this. Look at the region, right? As a region, it did not do well with this monsoon. I also want to argue, though, that our expectations based on the last 4 or 5 years are completely out of bounds as far as what we wanted this monsoon to do.
This happens quite a bit.
Yeah. The extent and the amount of rain that most of Arizona and New Mexico has seen in the last couple of years is crazy.
What I said in the beginning, we're at least in Tucson, we're only the 24th driest. There's 23 worse.
Yeah.
That being said, Flagstaff was number 1. Phoenix was number 3.
Okay. Yeah. And again, I was saying Southeast Arizona, right?
Yeah.
I'm trying to make our listeners in Northern Arizona not feel like we're whining. Oh. Even though we do a ton of whining, right? Because, you can't get any lower than that. I mean, in the period of record, right? So if it's 0, if it's the driest, it's the driest in the 70-year record. So it doesn't get much worse. Northern Arizona, this is not good.
So Lorena was basically Phoenix South. Okay, and
so we should actually
let's talk about what happened in Lorena. Right. So Lorena came in
about
September
the 22nd. I believe when it had been classified as a post-tropical storm or post-tropical depression was right around the 22nd.
Before we deconstruct what happened with Lorena specifically, and you can go over those characteristics, it's worth saying that on average, Arizona sees moisture from 3 tropical storms per year.
Oh, cool.
Yeah.
Interesting.
Yeah, I read that in a paper from Elizabeth Ritchie.
Right on. Yeah.
But the data set that she was looking at was 1992 to 2005. So it's a 13-year data set, but within those years, I think 36 tropical storms recurred and generated precipitation somewhere in Arizona. So
interesting.
I was surprised by that number. I thought we would see maybe 1 at the most, but
it's an important contribution.
Often makes 30% of.
Yeah.
And so there's an interesting quote here. I'm paraphrasing a little bit from that paper. It's the variability in the monsoon is associated with, and she goes on to explain different mechanisms. I'll summarize them as the position of the high pressure ridge, the passage of easterly waves aloft, and Gulf surges. And then she states, when the frequency, intensity, and or precipitation resulting from these sources decreases, other less regular moisture sources have the potential to contribute significantly to portions of summer rainfall. And that's what we saw this year with Lorena ended up for Tucson, 25% of its summertime rain, more or less.
Okay, so what happened in the end of September was it's one of those things that I always hope will happen. You're like, I hope there's a cool surprise in this monsoon season. And then a lot of times September 15th rolls around and you're like, we're done. It's not going to rain again until hopefully maybe December, right? But this was, and maybe to the credit of the forecasts, was that the expectation of the enhanced East Pacific storm season, which was exceptionally slow, right up until August, I believe, when it kicked on, and then has been through the roof.
Interestingly, right, like that forecast was in part based on an expectation of...
It was El Nino.
Yeah, El Nino,
so,
which sort of went away.
Yeah.
Then that's when the hurricanes really started to flare up, which is maybe getting the forecast right, but not necessarily.
Hey, man, it's a win. I'll take it. I'm not any better either. But it's the whole thing of now we've got we have a warm neutral condition, right? And it's like, what is that? I'm not sure. So that comes online. So this active jet story, as I was trying to build up to, looking at the monsoon ridge in the beginning of September, it was hanging on by a thread, right? And it collapsed. It basically went away. The westerlies and troughs of low pressure were coming in through the western U.S. Typically what that means for us is that the monsoon moisture gets shunted south and we just start to dry out. And it gets sunny again, it dries out, and my swamp cooler works better all of a sudden. So this is all about, of course it is.
Sorry.
Yeah. One of these storms ended up becoming just had a crazy kink in it. It was a low pressure system that came out of the Gulf of Alaska and sent a bowling ball south. It was a low pressure system, came right down the West Coast, and it came all the way down into Arizona. And its timing was impeccable because Lorena had come up and just basically dissolved in the northern Gulf of California. So the low came right down the Colorado River Valley south into western Arizona as that moisture was there. And it was a perfect meshing of gears. And it brought with it very cold air aloft, unusually cold air aloft for this time of year. And at the surface, we ended up having dew points that you could only dream of in the middle of the monsoon. So you crashed summer and winter together in a weather system and parked it over the state. And the other thing that was really interesting that wasn't even forecast was that the storm cut off, meaning that the jet stream left it behind. The jet stream went on its way and left the low over western Arizona. So it sat and it was spinning for 5 days.
Okay, so the low then helped create that atmospheric instability.
Yeah,
that
we can't generate lapse rates like that in the summertime here with a high overhead. You need a cold, low-pressure system with that kind of temperature associated with it to actually get a lapse rate of those. I mean, we ended up having the Storm Prediction Center started paying attention to Arizona for days on end. That doesn't happen.
There was a couple tornado warnings.
We had several severe thunderstorm watches over a period of days. We were in convective discussions day after day. Nothing else was going on in the country except the Storm Prediction Center was paying attention to us. So it was a very unusual situation.
Okay, so parts of Phoenix, actually, some of the parts in the superstitions received like 4 inches of rain.
4 to almost 5 inches of rain on one of them was in a single morning.
And this is where we should maybe caveat the total amount at the Phoenix airport because it didn't see that much from.
No, it had been very frustrating for Phoenix to see that go down. Yeah.
So really, while some parts of Phoenix got a lot of rain, Phoenix maybe got a third of an inch. The airport. When I say Phoenix, I mean the airport.
There was kind of this crescent around the northern part of Phoenix to the eastern part of it that did really, really well in that event. And then as you got to sort of center town, it wasn't as busy. And then one of the interesting things was that if you went out I-10 or I-8, they had epic supercell thunderstorms that dropped crazy amounts of rain. And that's the only part of Arizona that saw above average precipitation for the monsoon because the bar is so low and they had such epic rain in a couple of days of rain in September. That wasn't even really technically monsoon at that point.
So given what you said, though, where we had this collision between winter and summer, would you have expected there to have been more moisture in this event? Or do you feel like it delivered as much as it could have and it was a pretty epic event, just not at some of the measuring stations that I've noted?
It was one of those that I was let down because I wanted more action in my backyard, but it's all about me. There was some.
What did you get?
I think we didn't do bad. For the month, we got 2.6 inches, which is really good for a September rainfall. Inch and a half out of that multiple day event, and some actually damaging severe winds on the east side of Tucson, not too far from my house, from the beginning of that event as it rolled in. So the forecast for it was very good, up on the day of where the heavy rainfall was going to, because we had the Weather Prediction Center with its excessive rainfall forecast, and then the Storm Prediction Center, 2 parts of NOAA, coordinating with the local offices of really looking at the bullseye, which was going to be kind of Phoenix north and then parts of western Arizona. And it did well, and I think it verified with what the expectations were. Could it have been worse? I'm not sure. I think that the amount of severe weather that occurred with that event was pretty epic and made sense with what happened with that low pressure system.
So when we look back, in a few years when we all forget about the details of the season,
this gets lumped into that total. Right?
We're gonna see, in Tucson 85% of average or something like that. Maybe by then we'll have better ways of tallying up the spatial variability and metrics that account for differences across space and time, but we don't at the moment. And so would you argue that we ought to omit the Lorena event from the monsoon record? Or
You're just provoking controversy here, aren't you?
well, I mean, I'll answer it.
I know you want to strike it out.
I want to strike it out.
I know. I think we've had this discussion before. To what end? I just feel like we're heading down like some sports analogy here, where you're gonna take back a title. Like it's a dubious.
Is it the Lance Armstrong?
That's right. Yes. Was this
like
lapse rate doping?
Is this
going on?
Is this the monsoon doping scenario?
Yeah.
We get an extra slug of tropical storm in our
That's right.
Whatever.
Yeah, right on. Yeah. I know. This is the funny thing. So what's the point? Fell in the monsoon season. It's going to go on the record. Would it be any different than this happening in October? Probably not.
In terms of impacts, no. I mean, this is all an intellectual exercise about it does matter in the sense that if one of the scientific objectives is to understand how the monsoon is changing, right?
For that purpose,
then those statistics matter.
Yeah, I think for that purpose, and I think it's a really interesting exercise that I hope we can play with more, which is looking at the monsoon season and trying to ascribe a precip day to, is it a typical monsoon pattern is it
monsoonal?
Monsoonal, right? Yeah, with indeed the being in the subtropical circulation pattern. Is it an interaction then with tropical storm moisture? Can we carve that day out and maybe mark it there? And then can we say that this is actually a transition event that really is fall now in the monsoon? But this is the whole thing too, is this monsoonal moisture? Well,
here's the thing. Let's do the experiment where we take away Lorena, and you can still have that low pressure wafting down the coast and into our region. Would it have generated precipitation? Did it need that moisture?
That's a really good question. It helped. It may not have needed. I guess I would have to think back.
We certainly wouldn't have got 4 inches of rain. Without Lorena? You're on.
I know I'm being recorded right now. Yeah, I'm trying to think through. Like, there can be deep, high precipitable water just south of us, and it doesn't need a tropical storm.
Okay, so then how uncommon was that low pressure, that cutoff low that came in?
I think it was fairly uncommon. This is something that I should know, and I meant to look it up before, but what's the frequency of cutoff lows? I think they're relatively uncommon this time of year. They become more common later in the fall, and they're common in the spring, right? And it's usually because it's access to the westerlies. We shouldn't have that much access to the westerlies. And I have to point out here too, Tropical Storm Lorena and her moisture, that moisture was available at the beginning of the week and was gone, right? I mean, it was brought up into the circulation. The position of the low was funneling up Gulf of California moisture. It was part of it and some of the moisture at the beginning, but it wasn't necessarily the same moisture being recirculated in.
That's interesting. I was actually thinking that those 4 days were tapping into.
Well,
Lorena.
there was a bunch. There was actually Tropical Storm Mario,
right,
which was off the coast on the west coast of Baja. There was Lorena. And then the Gulf of California this time of year is plenty warm and giving off plenty of moisture. So the low, which we normally we think of, there's an honest to goodness thermal low that occurs in Yuma. That's part of the whole Gulf surge phenomenon, of having higher pressure, cooler air at the southern end of the Gulf causes that pressure differential. Well, it was a cold low in its own right. So it was still a low pressure system, it was much stronger, more persistent. And so it did some of the same function of being able to guide up that subtropical moisture from the Gulf of California and in the activity that was in northern Mexico.
You haven't convinced me.
I never do.
I also want to say, I think it is really interesting when we're looking at the contributions of these tropical storm remnants or tropical cyclone remnants. I mean, they can be up to 50-60% of the total monsoon precipitation.
Absolutely.
And I do think, maybe just for talking about it, sort of an intellectual activity of just trying to figure out what was a good and what was a bad monsoon. Yeah, we ought to try to distinguish between those years that received an inordinate amount of rainfall from these kinds of storms, which I would argue are not caused by the same they're not the monsoon mechanisms. They may be wafting into conditions that are influenced by the monsoon and therefore get convoluted.
Yeah, I think it's going to be tough to make a clean break.
Yeah,
quite honestly,
yeah, I think,
right? And they're kind of.
Can they be like an asterisk? Is this like the,
I think
the Barry
that's what
Bonds?
you're doing. You're Barry Bondsing this. You're going to asterisk a lot of days and a lot of years.
That's true. I mean, there's three. Like I said before, there's three of these events on average that come in each year.
Yeah, I mean, and so what about last year? So last year, monsoon's over September 30th by our, the definition that we've all gotten on board. And I think it makes a lot of sense when we think about the monsoonal pattern. I mean, that subtropical ridge and the upper level wind shift from west to east and then back to west again, it really happens in mid-September climatologically most years, right? Well, last year, much of Arizona ended up getting 2 tropical storms and an interaction with a low pressure system, not all that unlike what we saw in September. So that's not part of the monsoon total at all.
Okay, but Bud, right? Is it Bud one of them?
Yeah, that Bud was the beginning of last monsoon. It was June 15th.
15th, right?
Yep.
So that's not the one you're talking about? Or
No, I'm talking about last October.
Oh,
Do you remember last October? It was the wettest on record for Phoenix.
Yeah, that's right. Now I'm looking at the data for Tucson, and there was an event close to an inch September 20th. That was not a tropical storm.
I don't know. I don't remember.
I don't remember either. And it was just one day. So yeah. You're right. Yeah, it just came outside of the monsoon season.
I think it just gets messy when you get into September anyways. I think it's much less common in August. And so it's like core monsoon season is July, August, and then September is this strange month that has lots of interesting things that can happen.
Okay, so here are the numbers, though, from that Ritchie paper. Again, looking at just a 13-year data set. So we're only talking about 35 tropical storms that brought moisture into the Southwest. In September, 15 happened total. So that's the month that experiences, obviously, the most recurving of those tropical storms. And that's because the westerlies are pushing south. And as storms move north, they get entrained in that westerly flow. There was 9 in October, so there was still chances, and then none in November. So, yeah, just that's kind of a cool climatology of tropical storms that would be great to be updated, quite frankly.
August is busier in the East Pacific, but the potential for the action shifting into the Southwest is in September, and it's because of that transition pattern. It's because of that shifting around, that chance of recurving, and that interaction of the moisture that could occur.
Interestingly, in June, a few happened in June over that 13-year period, I think 2. And if we did update that record, or if somebody did update that record, Bud would be...
Yeah, I know. It starts to contribute to some rare cases, right?
So yeah, monsoons in the books. 2019 ended the streak, I guess, of a number of years in a row where we saw above average action. A reality check, Mike?
Yeah, I think it is. I think I had unreasonable expectations for it too. They were wildly unreasonable, quite honestly.
Oh, so I'm glad you pulled this up. So Mike just pulled up a figure that I want to talk about because I think it's illustrative. Well, why don't you explain this figure?
The idea would be just trying to assess the extent of rainfall across the state each day is literally just how much of Arizona saw precipitation on a given day, percentage-wise, just by using this gridded data set. So if it's the entire state, based on this index, this gridded precip data, saw it would be 100%. If nothing in the state saw it to be 0, right? And so it's just that extent. And so you can look at the climatology of that, and the climatology of the extent of precip peaks in late July, which is kind of interesting in its own right, and then plateaus a bit through August, and then gradually subsides in September.
But what I like about an attempt like this is really trying to understand the spatial extent of rainfall, because
that's right.
We could in Tucson have a banner year, but the rest of the state experiences very little precipitation. And again, this is sort of like trying to unpack the existential nature of this monsoon, because it is a kind of a unique thing depending on where you are. But to try to summarize that.
Yeah, we kind of grasp with how to summarize the monsoon and think of it regionally and it being a locally experienced phenomenon for sure.
And so the results of this...
It's the number of days that were above the median as far as the expectation for precipitation. So it's again, this is not done. But you could think of it as like how many days were monsoon days for Arizona. The point of even bringing this up was that we've had some fairly good, big, widespread years across Arizona in the last 10 years. And you have to go all the way back to like summer of 2011 to see something where all of Arizona suffers
has a lower value than this year.
Yeah. So in 2011 there were 46 quote unquote monsoon days where the extent was above the local median, the daily median, and then this year was 54. But the last couple, so we can go back to 2015, 78 versus 54 this
78
year.
Days.
78 days. 76
incredible.
in 2013, 68 in 2014. Last year was 60. So it's actually, interestingly, it's not that far off. So there's some aspects of this index that doesn't capture the extent above that. You know, it doesn't have some intensity aspects and it doesn't have some totals and aspects. But it's kind of on our way to start thinking about this as a more regional phenomenon.
But even by this metric, I think it shows the relatively wanting monsoon that it was this year for the most part.
Well, and I think if you go back prior to the last couple of years, there were runs of years like 2002, 35 quote unquote monsoon days, right? And that was June, July, and August were almost no shows. And then there was some rally in September, probably a tropical storm. 2003, 41, 2004, 39. And then you've got this run, like I was just explaining, since like 2012, pretty good years for the state. So I think that kind of goes back to the sort of emotional expectation for let's keep the rally going. And gosh, it just seems like the whole idea of conservation of misery here is like we had such an epic winter.
Is that a physical law?
I think it's physical law. It's in the same books as like Murphy's Law and that kind of stuff. We didn't deserve to have a good summer after the beautiful May that was doled out to us. So I was thinking we were on a run, but clearly we weren't.
So is this conservation of misery mean that
I'm thinking the winter's going to be great. Absolutely, yeah.
You think it's going to be great or bad?
Whatever. I think it's going to be great because of the conservation of misery principle. So that means that northern Arizona is going to have an epic, beautiful, wintry snow wonderland. We're going to have
the
something in the
conservation
middle.
of misery is not the continuation of misery.
No, it's that
the opposite.
That there's
something has to come in.
Something has to good. If you're miserable, then there'll be something to counteract it, and then vice versa.
Oh,
yeah.
Okay.
Well,
you heard
that's
it
my
first.
Forecast. Yeah,
Mike's
and
forecast,
so neutral,
based on
nothing to go
physical
on.
laws of conservation of misery.
Magic 8 Ball.
I think that's going to be the name of the podcast.
Yeah,
Conservation of misery.
Do you know my Magic 8 Ball actually dried out, so I can't even use it now as a forecasting tool? Did
that happen in July?
It probably did. Yeah, it's like literally a desert problem.
All right,
got to wrap it up.
Yeah, we've got to wrap it up. Okay, Mike. So monsoon's done. We're now entering into the slow season, as you call it. We'll see if October can produce tropical storms. We'll see where it goes. CPC's forecast sort of calls for slightly enhanced chances for above average precipitation in October, but I think that is only slightly better than flipping a three-headed coin.
Yeah, that's right. That's good. I need one of those. Hey, it's not brown. It's not a below average forecast. The fact that we're leaning wet, I do think it probably is. I haven't read the discussion that it is that.
Well, you can bank on warmer temperatures.
You can bank on warmer. We expect it to be warmer than average. That trend flies through.
It's so much easier to forecast when you've got like a robust trend.
Trend is
than it is when you're dealing with like noisy.
No, I know. Trend
data.
It's a forecasting tool, a sad forecasting tool.
Don't make a forecast when you've got no trend and a bunch of variability and
that's right. And no discernible oscillation in it. Yes, I agree with you.
Okay. All right, Mike. Yeah, we'll come back, and I think in a month we'll have a little bit more to say about forecasts for the winter. I mean, it's right now the ENSO forecast is calling neutral. That'll probably remain in place. That's looking kind of certain, but that those years have brought some of our wettest times here to the Southwest. So
and our driest too.
So everything's open.
Conservation of misery.
Conservation of misery. All right. Thanks, Mike.
See you, Zach.
That's why they don't get our humor, because
I know, because it's not that funny.
I love that. The conservation of misery. You know what we should do? We should
a band, an 80s post-punk band.
I'm gonna take this one. Sorry, I needed a second there.
Warm up.
Yeah, I needed a little warm up there.
All right.